Hey everybody, it's Mr. Mott. I want to talk about what happens when ionic substances dissolve. Let's first take a look at some ionic substances and some molecular substances. So on the right we have table salt, which is an ionic substance made of a metal and nonmetal, sodium chloride. We've got sugar in the middle, which is a molecular substance, and some borax as well. So you can see right away that the shape of the molecules in our microscope is very different. And the shape arises because of the way that the ions are connected and how all the molecules are connected and the bonds between them. Taking a closer look at salt, we see that each shape is very, very regular, and that has to do with the way that the atoms arrange themselves. So looking at it on a small scale diagram, we see that we have the sodium plus ions and the Cl minus ions. And when you have a lot of those, what they do is they arrange themselves in a very, very regular pattern in 3 dimensions. You can see that they're going to form a cube shape. So all salt particles will look like that cube shape under a microscope. So that's an important thing to recognize, is that salt and ionic substances form this very, very regular shape, which is known as a lattice structure. Now when we dissolve them, it's important to recognize and compare them to a water molecule. So a salt molecule is sort of very regular shape, positive ions, negative ions. A water molecule is a polar molecule with a partially negative charge on the oxygen and a partial positive charge on the hydrogen. So what happens when we put salt in water is that the water basically pulls apart the ions. You can see in this diagram. So basically the water molecules have a greater affinity for those ions than the ions have for themselves, and that's why the salt will dissolve. We can see in the top that the positive ion is surrounded by the negative portion of water, and on the bottom we see the negative ion coming from the salt is surrounded by the positive part of the water molecule. So it's important to have an understanding of when something dissolves, how does it dissolve and what's happening. And when you're talking about an ionic substance, the water molecules are going to pull it apart. Now, chemists are always looking for ways to abbreviate and write this down without having to draw pictures every time. So what we do is we write a dissolving equation, starting with our solid, NaCl solid, and we want to represent that this breaks down into its ions that are separate. So we write down the Na plus is separate from the Cl minus, and we give them both the designation aqueous, meaning dissolved in water. When we look at another substance like calcium chloride, CaCl2, we want to recognize what happens when this dissolves. So the calcium ion is separated from the 2 chloride ions. And the chloride ions are now separate. So when we write our dissolving equation starting with CaCl2 solid, we write that we have our calcium ion, which is aqueous. And now we want to represent that those chloride ions now are separate. So we put the 2 in front. So the 2 in front of the Cl's means I have 2 chloride ions. In the formula of the CaCl2 solid, the 2 is a subscript because those chlorides were connected. And that's the difference. If we look at another substance, iron 3 oxide, rust, and if this were to dissolve, the 2 iron ions would separate, and then you have the 3 oxide ions separating. Now, some of you may be wondering why is it iron 3 plus and not 2 plus? Well, you need the total positives to cancel out your total negatives, and you have a total of a -6 charge from the oxide ions, and so iron would have to be 3 plus for each to have a +6 to balance out those charges. All right, it's just a little aside. Writing our dissolving equation, we start out with our iron solid, and now that we have our iron 3 plus, and we have 2 of those, and then we have 3 of the oxides, 3 of the O2 minus ions. So we write them like that. Looking at another substance, one that can be tricky initially, is what happens when we take a solid that has a polyatomic ion. How would that dissolve? So you have your positive part, which is the barium 2 plus, and then the SO4 must be then together, because in an ionic substance you have one positive part and one negative part. so the SO4s stay together. So representing that in our balancing equation, once we have that idea, is very straightforward. We have BaSO4 solid, and it breaks down into its two ions. All right. If we look at something a little bit more complicated with some calcium phosphate, when this breaks down, we can see that we're going to have 3 of the calcium ions, and we're going to have 2 of the PO4 ions, and those PO4s are going to stay together as a group. So when we write our dissolving equation, we want to represent that we have 3 calcium ions, and they are separated, so I put the 3 in front, and we have 2 of the PO4 ions, so we put the 2 in front. Hopefully that's helped understand what happens when ionic substances dissolve and how does a chemist represent it in a dissolving equation. Thanks for watching.